welcome to this section of the course. We'll be using the addition and subtraction formulas for sine and cos here to solve some problems. So let's get to it. The first problem, we've been asked to show that this fraction 6 minus root 2 over 4 is sine of 15 degrees. Now obviously the fact that we have a number 15 there, it's uh, talking about, the question is hinting that our work is in angles. So uh, there is uh, no hints given to us, but you should be familiar with some of the basic uh, uh, angles. So we know that the basic angles are sine 0, 30, sine 45, sine and sine 90. So which of these angles do you think we could subtract so that we can get 15 degrees? Well, the difference between 60 and 45 degrees, the difference between 45 and 30 is 15 degrees. So uh, you you can do some trial and error and substitute values there, but I would suggest you start working with angle 45 and 30 degrees there. Alright, so these 45 minus 30 is 15 degrees. So if we use the double angle formulas for subtracting sine here, what we get is that we will have, we're going to call our alpha to be 45 degrees and our beta to be 30 degrees. So we'll have sine of 45 multiplied by cos of 30, and we're going to subtract cos of 45 and multiplied by sine of 30 degrees all over, well, there is no denominator there yet. So what are these? What is sine of 45 is a root 2 over 2, cos 30 is root 3 over 2, I believe. Let me just double check. Yeah, so root 3 over 2 there. So that's looking good already, because I can see on top of this fraction I will get a root 6. I have a minus sign here, which is good. So is what the sign on top of that fraction. Cos of 45 is again root 2 over 2. Sine of 30 degrees is a half. So multiply out this fraction, we'll get root 6 over 4, and this will give us root 2 over 4, and that is the right side of the that we were asked to do. So that ends this question. That's the end of this problem. In this example, we've been asked to calculate tan of A plus B given the formula to us, and knowing that we have sine of A to be a reflex angle, because any angle over 180 degrees is reflex, and cos of B to be negative 12 over 13, where B is an obtuse angle. Now, it's always best to picture these for yourself. These angles here, reflex angle falls in the third quadrant, and this is a famous Pythagorean triplet. So the fact that hypotenuse is 5, hypotenuse is always positive, and the opposite side is 3. So angle A falls here. Therefore, using Pythagorean triplets, we know the number there, it must be a 4, but make sure you use negative, because in the third quadrant the x value there is obviously on the left-hand side of the y-axis. So we will why am I drawing this? Because somehow we need to figure out what tan of A is. So reading tan of A from this picture, we know tan is opposite over adjacent, and negative 3 over negative 4 will simplify to positive. So let's look at this obtuse angle B, and we know obtuse angles are between 90 and 180 degrees. Therefore, our triangle falls in the second quadrant of unit circle here, and the fact that the the cos is negative, that means that the adjacent side is a negative 12 and the hypotenuse has to be always a positive number. Therefore, there is another famous Pythagorean triplet, 5, 12, and 13. So we can read tan of B from this figure to be opposite over adjacent, which is 5 over 12. I'm going to put the minus, uh, it doesn't matter as long as it's in that equation, in that fraction there, minus 5 over 12 or 5 over minus 12, same thing. So substituting those two values for tan of A and tan of B into this formula here will give us 3/4 take away 5/12 divided by 1 minus 3/4 multiplied by negative 5/12. Now you can put those numbers in your calculator and you should get an answer that simplifies to 16 over 63. Okay, I'll see you in the next video.